Okay, so today we're talking about quantum key distribution. And if you have a few $1,000,000, you can buy a quantum key distribution system off the shelf from one of a number of companies and put it to work. And China has recently demonstrated quantum key distribution through satellites. So this actually is something unlike anything we've talked about so far, more or less, that works with today's technology. So what is quantum key distribution? So suppose you are somebody, and so these are the traditional cryptography participants in cryptographic protocols. And I don't know who started Alice and Bob. And so Alice and Bob want to communicate, and they want to communicate secretly. And there's an eavesdropper, whose name, of course, is Eve, who wants to listen in. So that's the scenario of, well, probably thousands of cryptography papers in which Alice, Bob, and Eve are all the participants. And, RSA, Ron Rivest, Adi Shamir, and Len Edelman showed how to do this with computational security via, using the fact that large numbers are hard to factor. So that's what is actually used in practice nowadays. Anytime you buy something over the internet, you multiply two very large primes together and hope that nobody knows how to factor it, because otherwise they could steal your credit card. Although I should say that if you had a quantum computer that could factor, stealing people's credit cards from transactions is around the probably the 100th most lucrative use for it. So your credit card is, when you buy things from Amazon, is probably pretty secure unless someone breaks into Amazon's server. So there we are. So what quantum key distribution does is it uses secure. So quantum key distribution, Alice and Bob start by not having anything in common, any secret information in common, and end up with secret keys that agree and that nobody else knows. And this is secure not through computational security, saying that there's a task that could be used to break it if someone had a powerful enough computer. Secure because of quantum mechanics. So it's secure because of physics principles. And I'm going to explain that to you. Actually, quantum key distribution has a wonderful story behind it, which you can read in A Brief History of Quantum Cryptography, A Personal Perspective by Gilles Bressard. And so Gilles Bressard was, I think, swimming on the beach at a computer science conference. And Charlie Bennett, who he didn't know at all, came up to him and started talking about this weird quantum physics stuff. And so originally, Charlie Bennett got this idea from Stephen Wiesner, who went to graduate school. Well, let's see. They were undergraduates together, and they kept in touch after they went to graduate school. And they, Stephen Wiesner had this weird idea for using quantum mechanics for various computational tasks. And one of them was banknotes. And so he told Charlie about it. He wrote up a paper he submitted to IEEE Transactions of Information Theory, and it got rejected. So he just didn't do anything on it. It eventually got published probably more than 10 years later when Charlie persuaded the editor of SIGACT News to include it in SIGACT News. SIGACT being, I guess, special interest group of the Association for Computing Machinery. So, but this conversation on the beach happened before all that. And, you know, Charlie Bennett told Gilles Broussard about his ideas and about Wiesner's ideas, and they eventually came up with what is known as BB84, which is Bennett, Broussard, and it was published in 1984 in an extremely obscure proceedings of a conference that took place in India. And probably because, you know, they submitted it to, I assume they submitted it to other places and got rejected, although let's see if it says that anywhere here. Yeah, they submitted it to Stock and failed to have it accepted. Nice euphemism for rejected. And so then they submitted it to this computer science conference in India, and it got accepted and got published. Anyway, it was a very clever idea. It was based on Stephen Wiesner's ideas, but fleshed out to make them more rigorous somehow. And let me tell you what the idea is.